Hey everybody, this is Larry. This is day 27 of the February Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think. So I'm still in Medellin. I'm in Colombia. I want to say thank you for all the people who have donated the last day or whatever. Appreciate it. Hopefully we'll hopefully things will go well, I guess. But regardless, there's still a lot of situations going on, so we'll see how that goes. But definitely every bit helps, and you can figure out what to do in other ways. Let me know, and we can figure out what we can do. But today's problem is going to be maximum width of binary tree. So what is a width? Okay. Maximum width along all levels. The width of one level is the length between the end nodes. What? I don't know that I understand this, so let's take a look at the example. The third level of length 4, because 5, 3, no, 9. The maximum width third level with length 2, 5 and 3. Length 3 and 2. Okay. So So basically the leftmost node and the rightmost node. Okay. How do I want to represent this? Let's see. I mean, so the way that I'm gonna probably end up doing is just by recursion, and then for each level we find out the I guess so, right? Just like the max and the min, and there is a symbol, maybe a symbol way of representing like the node number from left to right, and that is of course using the 2 times I formula, like I plus 1, I plus 2. So I think that should be good enough to at least that should be good enough. So I think that let's get started. Why is my monitor so dirty? Now I just realized that because I've been kind of moving it around a little bit. I'll wash my monitor. Okay, anyway, so yeah, let's start on that. And basically I will have let's just say leftmost. What do you call it that? Is you go to let's just connection dot default. No, let's just do default dict of let's say leftmost. So we want to have an infinity number. So let's just say lambda of infinity, and then rightmost is the same, but in the other direction, right, of negative infinity. And then now we just do a recursive thing, which is we go node and current node number, say. So let's just go num, and then the idea is that, okay, so this current node, it has a number. I guess we should also factor in the level. You don't need all this, but it makes it easier to do some of this stuff. So then leftmost of level is equal to min of, because the left would be the min, so you do min of this and the num, and then the rightmost you do the same thing, but in the other direction, right? And then now we'll be able to go if, I guess I have to add some stuff, which is that if node is none, then we return, obviously. Otherwise, if node is not none, then we can just go node.left, level plus 1, num times 2 plus 1, and then again, same thing, but that. And then I think we should be good. We're going off root, level 0, and nums up, I think 0 or 1, maybe 0 is good. And then now we get for x in, or for level, say, in leftmost.keys, and you can prove to yourself that for every level it should also have a corresponding point in right. But then now here, so best is equal to the max, right? So best is equal to, say, 0 or maybe 1, I suppose. Yeah, doesn't really matter. But so best is equal to max of best, rightmost node, or rightmost node of level minus leftmost level, and then plus 1 for the off by 1. It's not off by one, but you add one because you count the node with. That's how you count the number of nodes on inclusive bounds, right? So yeah, let's give it a spin. Let's give it a spin again. And yeah, it looks good. Let's give it a submit. Hopefully I don't get it wrong for something silly like 0 nodes or something like that. Oh, did I forget the mod? Maybe I misunderstood this then. Oops. No, I mean I didn't forget a mod, but did I misunderstood some part of this? Or maybe I just messed up somewhere. That's weird, actually. Let's see. What is this? Can I visualize this? Let's see. Oh, I see. Why is that? Why is my thing wrong though? Did I use the wrong formula? Why is that wrong? I mean, I get what it's doing. I guess my formula is just wrong, to be honest. Because maybe? Oh no, it's very weird. Let's take a look at the leftmost, rightmost real quick. Yeah, better visualization. Right, what is all this stuff? Oh, devoutics. So this is, I guess we'll put on 2 lines. That is a surprisingly, right? Should it start at 1? Maybe that's why. Let's see. Let's say it start at 1. Come on, friends. Oops, still wrong answer. Still the same. Oh, different wrong answer, but still a wrong answer. So that's not great either. I thought that maybe this formula only works for complete tree, but oh, I see why. Because my infinity is not big enough. I was just lazy about infinity, to be honest. But okay, let's just say infinity of. Okay, so I was just being dumb. I think the silly thing is I made the same exact error on the virtual contest earlier, so that feels a little bit sad. Let's give it a submit again. I gotta stop doing that maybe. But yeah, 690H3, yay. So the reason why, excuse me. The reason why, so I get this question a lot, why I use, I don't know, I mean, obviously I could use this, but I use this, right? And the reason is just, well, one is that is my default, so so this one I should really have thought it through a little bit. But the second reason is just because sometimes in some problems, if you keep it with this, it auto promotes it to like if you do operation with the infinity by accident or by default, it automatically changes to flow, and also infinity does some like weird funky stuff. So that's why I try to do it, keep it an int. But this time I was just sloppy and got it messed up. What is the complexity, right? The complexity is just going to be linear time, O of H space. Linear time because we look at each node once, and linear space because, O of H space because for each level we have, well, 1 entry in the thing. Of course, that's going to be linear in the worst case, so linear space as well in the theory. Let me see what I did about 2 years ago. Okay, so I feel like, so this, I essentially did the same thing, but I did not use default dict, so I got it right without using it. Yeah, and as you can see, this actually thing doesn't really matter, but cool. Yeah, yikes. But that's all I have for today. Stay good, stay healthy, to good mental health, and I will see you guys later. Bye-bye.